All right, now we are going to do a little bit of application with exponents, scientific notation. I'm going to guess that some of you have seen this before. If you haven't, that's fine. And this is going to be really useful to you in your chemistry courses, biology, etc., when you're dealing with very large or very small numbers. Okay, so the idea with scientific notation is that you are going to express a number, okay, whatever number in standard notation, in this kind of condensed form, a times 10 to the n. And a has to be a number that is between 1 and 10, and n is going to be an integer. Okay, very important. Okay, so 0, 1, 2, and negatives. Okay, that's totally fine as well. But a cannot be a double-digit number, in essence, and it can't be 0. Okay? So, some examples, something like 3.2 times 10 to the 12th is fine. You could have 6.1 times 10 to the minus 15th, etc. That's fine. Some things that are not good to write, 0.123 times 10 to the 12th, okay? This is being violated. The 0. whatever, you can't have that because it says a has to be a number between 1 and 10. Okay, inclusive on 1, exclusive on 10. All right, another thing that you cannot have is like 21.5 times 10 to the minus 32nd. Okay, that's not okay because again, you have a double-digit number. A has to be a single-digit number between 1 inclusive and 10 exclusive. Okay, another thing that is not good to have is something like 3.2 times 10 to the pi, okay? N has to be an integer, pi is not an integer, okay? You're not going to encounter that situation, but just as a heads up, okay? You have to be able to convert between scientific notation and standard notation. So, there's different ways that students do this, and if you have seen this before, likely you remember, oh, you just have to move the decimal over a certain number of positions, and that's really convenient because we have a base 10 system. So if that works for you, great, but I think it could, if you start memorizing rules, you're going to get your rules mixed up. So let's just maybe take this one step at a time. To go from scientific to standard, okay, when you're going this way, I'm just going to tell you do math, okay? So literally, right, think about this as 8.1 times, and then 10 to the third is 1,000. So then all you have to do is do the math. So get out your calculator, do 8.1 times 1,000, and you're going to end up with 8100. Let's see, that should be it. Yeah. Negative 8100. The other way that if you remember about moving decimal places, you could say, oh, well, it's 8.1 negative, and then you have to move the decimal place 1, 2, 3. Since we have a positive exponent, you would move it to the right in going from standard or scientific to standard. Okay, and then if it's a negative exponent going from scientific to standard, you would move it to the left. Okay, now from standard to scientific, this one is where you have to imagine you're going to put the decimal after the first non-zero digit. Okay, again, decimal after first non-zero digit. And then the number that you get after is going to be that value of a. So 2.0071 times 10. And now we just have to figure out the exponent. Okay, now the exponent is going to pertain to the number of decimal places you move, so the number of powers of 10 that you've changed. So let's see, in total, the total difference in number of decimal places is 1, 2, 3, 4. Okay, so I need to decide if it's positive 4 or negative 4. Okay, that's my goal. Okay, now the way I tell students to remember this is the number that you started with, is it a really large number? If it is, you're going to have a positive exponent. If it's a really small number, like this one, you're going to have a negative exponent. Okay, so that's how I decide between positive and negative. The other thing that you can do is that you can, again, if you remember your left and right, like moving the decimal place left or right rules, if that works for you, hey, go for that. Okay, so now just do a couple more examples, and I'm going to have you pause the video, try the next two on your own. Great, and here you can see the answers that I got, so go ahead and do those. The last two examples are a little interesting because you're going to encounter these in homework, and these are the kind of the standard level of difficulty that we expect in the course. So you need to be able to do math and then express something in scientific notation or vice versa. So for this, what I do, if I know I need to work in scientific notation, is I work with both of them in scientific notation from the get-go. So 3.0002 times 10 to the fourth, oops, and then times, and then 5.08 times 10 to the minus 2. Okay, and now all I do is I do the math. Okay, so I can multiply the a's, so multiply the 3.02 and 5.08, and then I'll multiply the 10 to the fourth and 10 to the minus 2. The 10 to the fourth and 10 to the minus 2, that's really easy for me to do because that's just plain old adding exponents. Okay, 10 to the 2. Okay, and then for the other part, if I do that, let's see what we get. I got 15.25-ish, okay, and so here I truncated. If we want to round, that is perfectly okay, and that's kind of the expectation that your chem faculty have, is that let's just write this as 15.3. Okay, but now, is this in scientific notation? No, so I need to convert it, and 15.3 on its own is going to be 1.53 times 10 to the first, and then there's still this times 10 to the second hanging out at the end, so then at the end of the day I get 1.53 times 10 to the third power. Okay? Alright, so now I encourage you to try this last one on your own. Again, what I would do is multiply the 4 and the 3 together and get 12. Okay, so pause the video before I go through this all. But I would get 12 and then combine the powers of 10. So I get a whopping times 10 to the 64th, very large number, okay, over, and then I would do 240. Okay, and if I want to do this in scientific notation, this would be 1.2 times 10 to the 65th, and then divided by 2.4 times 10 to the second, and then simplifying here, okay, this is going to be 0.5 when I divide the 12 and the 1.2 and 2.4, and then times 10 to the 63rd. But now this is not in scientific notation, so when I put it in scientific notation, I get 5 times 10 to the 62nd. I need to take one of the powers of 10 and move it in, so I get that A between 1 and 10. Alright, so scientific notation, we'll get more practice with this in this course and in your other science courses.